Now we're going to talk about graphing and analyzing a quadratic function. Some key vocabulary terms. A parabola is the graph of a quadratic function. It will be in the shape of a U. The vertex of a parabola is the point at which the maximum or minimum value of a function occurs. So that's the higher the low point is the vertex. The actual highest point is called the maximum. And that's not just for quadratic functions, it's also for polynomials with degree greater than 1 also. And the minimum is the lowest point in a graph. So the first thing I'm going to show you is to write an equation, quadratic function in standard form. And I want to remind you that the standard function or the parent function is ax squared plus bx plus c. And I want you to notice the exponents. 2, 1, and 0. So you want to put the exponents in descending order for it to be in standard form. So this is pretty simple. All you have to do is just write y equals. Now you want to start with the squared term, so it's x squared. And then the x term is a positive 3x. Remember, if there's no sign in front of it, it's a positive. And then the constant is a negative 5. So that's how you do that one. That's the answer to that one. Okay, this one is y equals, the squared term is a negative 5, so negative 5x squared. And then there is no x value, but there is a constant, which is a positive 6. And for the final one, y equals, the squared term is 3/4 x squared. The x term is a negative 5/10 x, and then your constant pi is a constant. It's an irrational number, so the constant is negative pi. Now we're going to graph quadratic functions and identify key parts. For each function, complete the table of values, graph the function, and identify the maximum or minimum of the function. So what we're going to do is I'm just going to take each one of these, and everywhere you see an x, you would put a parentheses and then the number. And I apologize, when I typed this, I typed it incorrectly. The equation should be y equals x squared plus 4x minus 1. Okay, so here we go. So you're going to x squared, you're going to do the negative 3 is going to go in parentheses. Negative 3 squared plus 4 times negative 3 minus 1. So that's 9. Negative 3 times negative 3 is 9. 4 times negative 3 is minus 12 and a negative 1. So 9 minus 12 is a negative 3, a negative 3 and a negative 1 is a negative 4. Okay, the next one is negative 2 squared plus 4 times negative 2, forgot the 4, minus 1. So negative 2 times negative 2 is 4. 4 times negative 2 is negative 8, and then minus 1. So that's a negative 9 and a positive 4. So that's a negative 5. Okay, negative 1. Negative 1 squared plus 4 times negative 1 minus 1. So negative 1 times negative 1 is 1. 4 times negative 1 is negative 4. And then minus 1. So that's a negative 4. Okay. 0. 0 means that anything where you have an x is gone, because 0 times anything is 0. So 0, negative 1, just the constant term. We didn't even have to plug that one into the function. And then negative 1, I already had that. Again, I'm sorry, that's a typo. That should be a positive 1. So 1 squared plus 4 times 1 minus 1. 1 plus 4 minus 1. 5 take away 1 is 4. Okay, I'm going to graph this. Negative 3, negative 4. 1, 2, 3, 4. Negative 2, negative 5. Negative 1, negative 4. 0, negative 1. And 1, 4. Parabolas have symmetry, so that's why the 4 is 1 unit away from the vertex on each side. So you can kind of sketch it. We're just sketching these. Okay, so that's your parabola. Now it says after you graph it to tell what the minimum or maximum is. Well, here's how you tell. Maximum has a high point. So it's actually going to be an upside down parabola. Minimum has a low point, so it's going to be right side up, look like a smiley face. So this has a minimum value at, okay, the vertex, negative 2, negative 5. That's the turning point, then the minimum value, the vertex. It's known as all of that. Okay, the next one. Now you have to be careful when you're plugging into this equation because that negative sign is not being squared. It's only the x that's being squared. So when you plug it in, it's going to look like this. Negative 2 squared plus 8 times 2 minus 13. So 2 times 2 is 4, so this is actually going to be a negative 4 there. 8 times 2 is 16, and then minus 13. Okay, so I like to do the negatives first. Negative 13 and a negative 4 is a negative 17, plus 16, that's a negative 1. Okay, the next one, negative 3 squared plus 8 times negative 3 minus 13. So that's negative 9. 8 times negative 3 is negative 24 minus 13. Okay, that's all negative there. So a negative, so it's going to be a negative. Let's make sure I did that right. Negative, and then 8 times x. 8 times negative 3, negative 24, and a negative 13. So this is definitely not even going to fit on the graph here. That's a negative 23, negative 36. I apologize. I see what went wrong there. I was trying to figure out what I did wrong because I knew that number couldn't be right. I plugged in a negative 3 instead of a positive 3. So let's try that again. Sorry about that. Okay, let's try that again. So negative 3 squared plus 8 times 3 minus 13. So you've got negative 9 plus 24 minus 13. And that is 2. That makes it a lot better. Okay, so we've got negative 4 squared plus 8 times 4 minus 13. So that's negative 16 plus 32 minus 13. And that is 3. Okay, let me move this down a little bit. Okay, so negative 5 squared, oops, got to put that in parentheses, plus 8 times 5 minus 13. So that's negative 25 plus 40 minus 13, which is 2. Negative 20, negative 38 plus 40, yes, 2. Okay, so this is negative 6 squared plus 8 times 6 minus 13. So I really don't even have to do this one, and let me explain to you why. We know that parabolas are symmetric, and in other words, one side looks like the other. So once you find your vertex, in other words, where your numbers are repeating, that number in the middle is your vertex. So once you find that, then it repeats. So notice the 4, 3 has a 2 and then a 2. So negative 1 needs to correspond with negative 1. So you could figure it out, but as long as once you find your vertex and you start repeating the numbers, it's symmetrical. Okay, so 2, negative 1 is right here. 3, 2, right there. 4, 3. 5, 2. And 6, negative 1. So that one, our last one, sorry, I can't draw with this board very well. Our last one didn't show the symmetry, and this does. Now, as I said before, the vertex is the turning point, and since this parabola opens down, it is a maximum. So you have a maximum at 4, 3. Okay, the next one, x squared minus 1. Well, 0 squared is 0. Take away 1 is negative 1. Negative 1 times negative 1 is 1. Take away 1 is 0. Negative 2 times negative 2 is 4 minus 1 is 3. Negative 3 times negative 3 is 9 minus 1 is 8. And 16 minus 1 is 15. So we won't get all of these to fit on here, but we will get some of them. Now, I have a problem here. I don't see a vertex, so we're going to talk about that in a moment. So 0, negative 1 is right here. Negative 1, 0. Negative 2, 3. Negative 3, 8. And then the negative 4 won't fit on there. I only have part of a parabola here. And I don't know, I can assume that this might be the vertex here at 0, negative 1, but I really don't know that unless you know something about the quadratic formula. Okay, I mean about the quadratic function. Let's work backwards. Let me just show you what I mean by that. So on the x's, we were subtracting 1 each time, so let's add 1. 0 plus 1 is 1. Now when you put that into the graph, 1 squared is 1, take away 1 is 0. So 1, 0, now you can see that you have your symmetry, okay? So we don't need to sketch the whole thing because we know the turning point right here. Okay, so the turning point was right here because the numbers above and below are repeating themselves. So that's the vertex. And since this is opening up, it's a minimum at 0, negative 1. Okay, the next one. As a part of her math homework, Kylie is graphing a quadratic function. After plotting several points, she notices that the dependent values are increasing as the independent value increases. She reasons that the function will eventually reach a maximum value and then begin to decrease. Is she correct? Why or why not? Well, It really depends on your situation, because if she's looking at the left-hand side, those would be increasing until you get to the vertex. But if she's looking at the right-hand side, they don't start increasing until after the vertex. So she might eventually reach a maximum value, but in this case, it would be a minimum value. So she's not necessarily correct. She could be a little bit correct, but not totally. She's not necessarily correct. She may be just looking at data to the right of the vertex, so it would never turn and decrease.